everyone. Am I audible?
Good afternoon, sir.
Good afternoon, Neeraj. So let us start. So in this lecture, we will discuss about one of the very popular simulator that is called as Cloud Analyst. So before going to the hands-on related to Cloud Analyst, so you have to follow certain process. So let me share the process in the chat box. So there is a 6-step process I have given in the chat box. Also, let me post in the group also. At a point of time, if you are interested, then you can also follow this process to start the simulator. In group, I have already said this process actually. If you go to the readme file, readme.doc file, in that file you will find this 6-step process. So before running this particular simulator, uh, you make sure that you have installed JDK. Okay. So most of the computers are having Java. I don't think that you need to install, but still, if you don't have JDK, so install the JDK. I have given the JDK version as 8U181 Windows X8 X64, but based upon your compatibility of your system, you install the latest JDK. Okay, the first step is you have to install JDK. JDK is your Java development kit. So if you are playing some games or some high-level applications in your computer system, so I think you have JDK in your system. So not necessarily this particular version, you install the latest version of the JDK. That is our first step. Okay. So second step, you have to install an IDE. Okay. Any IDE you can install, but the most compatible IDE is NetBeans. Okay. Any IDE stands for your integrated development environment. So any IDE you can install. I think most of you are writing some Java codes. So I think you have also IDE. But if you have NetBeans, then it is very easy. But other IDEs also you can use. So I have also mentioned NetBeans. The version is 8.0.2 Windows, but you can use any version of NetBeans also. Right? These are the two primary requirements for running the tool Cloud Analyst. And in our group, I have already said one zip file, that is cloud_analyst.zip. All of you please download. If you have not downloaded, you have to download that zip file and store it in a folder. Cloud_analyst.zip file. So just download that simulator, that zip file. The size is very, very small, so you need not worry for the size. But this NetBeans size and JDK size may be little bit large. Okay, so let me download and store in a folder. Okay, let me share my screen first. Okay, so I'm repeating the step. First, you have to install JDK, the latest version of JDK, or any version is fine. Then you have to download Cloud Analyst. After JDK, you have to install actually an IDE. So the IDE I have considered here is NetBeans. Then I have created in my D drive one folder called Cloud Analyst. Inside that particular folder, I have pasted this cloud_analyst zip file. and extract this zip file. You can click extract all, paste in the same folder. I think it is a very small file, so it is in some MB. It is a 4 MB file, so it will not take much time. So you can see in my D drive, I have a folder called Cloud Analyst. Inside that folder, I have Cloud Analyst zip file, and I have extracted that zip file. Okay. How many of you have done this one? Have you downloaded NetBeans and JDK? Vishal has done. Okay, very good. Neeraj has done. What about others? Please download NetBeans and JDK. Anyhow, this Cloud Analyst folder I have shared with you. You can download from the group and extract it. Put in a particular folder and extract it. Download underway. Okay. Okay, let me tell you some theoretical aspect. Then once it is done with all, then we'll start doing some experiment related to Cloud SIM. So you may ask me a first question that we have already seen AWS, right? So why I am telling you about another tool that is called as Cloud Analyst. See, AWS is providing you an experimentation. Okay, AWS is providing you an experimentation. Whatever you are doing in AWS, whether it is EC2 or it is identity access management or it is S3 simple storage service, these are done in real life. Okay, you have really created an instance. You have really hosted a particular website. You have stored some objects into the bucket. That happens in real life, right? Any modification you are doing, it is affecting your online work, right? Somebody, suppose you have deleted S3 bucket. So if your clients are trying to access your S3 bucket, they are not going to get it, right? If you have deleted the users in IAM, then your users are discontinued from the service. And practically, if you see, for a long-term plan or a long-term service, if you use AWS, you have to pay for it, right? You have to pay some amount to AWS. Like, yeah, I told you, you can go for billing dashboard and you can see what is the bill you have to pay, right? So now my free trial for 12 months is already over. So I have to pay whatever experiments I'm showing you. For that I need to pay, but the amount is very minimal, right? But that is called as your experimentation. But here by this tool you can do simulation, right? So I'll share this research paper with you. This is the research paper related to the Cloud Analyst. So the paper name is Cloud Analyst, a cloud SIM based visual modeler for analyzing cloud computing environment and application. It is written by one of the very famous author of cloud computing by Professor Kumar from University of Melbourne, Australia, Department of Computer Science and Software Engineering, and their lab name is Clouds Lab, right? Cloud Computing and Distributed Systems Lab. So with a group of people, Professor Bhuya developed this tool long back, not a new tool, this one, but it is widely accepted because this tool you can be used by the developers to develop some kind of application without paying any money. As you know that for cloud computing, especially the a small business to medium business or small enterprises to the medium enterprises, people are attracted towards the cloud. But earlier what happened, developer has to do everything. Developer has to design a simulation experimentation environment. Developer has to deploy it. Developer has to host the applications. All the works are done by the developer. So it is very much difficult for a developer to come up with some solutions, okay, which can do deployment, hosting, managing. All these things are not possible by the help of developer. In fact, developers are facing a lot of difficulties. But through cloud computing, what happens? Developers should focus on only the application logic part. They are not now bother or facing difficulty with deployment, because deployment is done by the cloud service provider. But if you go for real life cloud service provider like Google, or you can go for Amazon, you can go for other cloud service provider. For these provider, actually we have to pay. In order to use the services, you have to pay for that particular services. Okay. But if it is a small application like S3 case, you have stored some file and verified it. It is okay. But if somebody wants to try with 500 GB, somebody wants to check some experiment with let's say 16 CPUs, or let's say uh, 64 CPUs. So it is very difficult, right, for experiment purpose. Like I told you, elastic block storage in Amazon S3, you can change elastic block storage size from 8 GB to 100 GB. But once you extend to 100 GB, you have to pay for it, right? So, in order to avoid this problem with the real life cloud provider, there is an alternative that is called as cloud analyst. Okay, and the cloud analyst, as I said, it is developed. It was developed at the University of Melbourne, Australia, and it was built on top of Cloud Sim. There is a simulator called Cloud Sim. You can see here. This is the cloud analyst architecture. I'll share this research paper with you. This is your cloud analyst architecture. In cloud analyst architecture, you can see there is a cloud sim toolkit. Okay. And on top of cloud sim toolkit, you have cloud sim extensions and you have GUI, graphical user interface. So by combining these three, there is a graphical user interface developed that is called as cloud analyst. So you no need to write code for it, right? Rather than simply click some buttons to create data centers, click some button to create a user, clicks some buttons to modify some configurations that you can do, right? And that's why this particular simulator is a popular simulator. And this is the cloud analyst GUI. Once you have downloaded everything, you can see this is just like a dashboard. Once the screen is coming, then I think your configuration is okay. JDK you have done, NetBeans you have done, you have extracted the cloud analyst folder, and you have successfully executed. Okay. So now I hope all of you have downloaded NetBeans, JDK, and cloud analyst from our group. If you have not downloaded, you can simply listen this lecture, or you can see if you are with your friends, you can do in your friend's computer if it is working. Otherwise, later point of time, you can try. Okay. So let me open NetBeans in my computer system. Yeah, NetBeans IDE 8.0.2 is there in my system, but I know it is quite old. So you can go for the latest one. Okay. Or other IDE like Eclipse. Most of the people are nowadays using Eclipse. They are using Luna, right? So such IDs are also you can use for cloud analyst. But NetBeans it is too easy, but others also it is okay. So it is built on the top of cloud sim. Okay. Let me delete this one. I have already created earlier. Okay. Now I have deleted it. Right. So this is the initial screen you will get once you open the NetBeans IDE. Okay. Now what you have to do, we use NetBeans for Java, writing code of Java. Then you have to go to file. Okay, file. So we are not creating a project, we are opening a project. The project is already written. If you want to write code, you are writing new project or you are creating new file. But here you have to open the project. Once you open the project, go to your computer where you have stored your cloud analyst. In my computer, under D drive, I have a folder called cloud analyst. Inside that folder, I have cloud analyst. Okay, and I have to open it. Okay, you can see there is a mug, coffee mug. It is showing a coffee mug here. It is showing means it is okay, means you have installed properly. Okay, and simply you click open project. Okay, so what you have to do, you have to click file, go to open project, go to your respective folder where you have stored your cloud analyst, extract your cloud analyst folder. So you can see in the chat box I have written the steps. And let me share the steps again. So first step, second step is done. Third step is you have to open the NetBeans. Fourth step is you have to go to open file, open project. Fifth step is to provide the path of your cloud analyst folder. So in my computer, it is in the D drive. On D drive, there is a folder called cloud analyst. Open that folder, extract the cloud analyst folder, and you can find a coffee mug, right? Coffee cup, right? So that you have to select, simply open that particular project. Then you can find there is a source package and library. The details about this simulator you can find under these two folder. Okay, after this it is done. Those who are using other IDs also you can follow the similar type of process. How many of you have done till now up to this? Okay, Neeraj done. Okay. Saurabh, have you downloaded? Saurabh.
Yes, sir.
Okay. So how to run a project? By clicking this F6 button, you can run a particular project, right? So if you click this run, so it is showing some error. No need of this error. And it is asking that cloud analyst class was not found in the. Okay, it is no problem. You can simply click OK. So if you are getting this world map, then up to this we have followed the proper procedure. Okay, if you are not getting this one, please write in the chat box or you can unmute and ask your problem. So this is the initial screen you will get once you run your NetBeans. Okay, the main purpose of cloud analyst is that any cloud developer, they want to test their application without paying money. Okay, without paying money, without spend anything, they can simply download this cloud analyst and they can know what are the things behind the cloud. Yeah, you got the GUI screen. So this simulator is a very, you can say, is widely accepted in the academic community. Also, this simulator is used in various real-life applications in China and other places. Okay, China Railway also uses the Cloud Sim and Cloud Analyst simulator. So now you can see there are 5 buttons. One is configure simulation, define internet characteristics, run simulation, exit, and show region boundaries. Okay, and there is a help button, but there is no information in the help. You can click help, click about. It will tell you the version of this simulator and who created this simulator. The first author of this paper, if you see, Bhatia, right? His name is mentioned as the developer of this particular simulator. Okay, there is no other help you will get. Right? His email ID is given here. If you want further modification, you can do it. Okay. Now let us understand one by one. So this is a world map, and here you can see something written in red color that is called as DC1. What is DC? What is DC? Can anybody tell? What is DC? What is the full form of DC? Anybody? Data center, yes. Sujata madam mentioned this is data center, right? So you know about data center. Okay, I told you in Amazon EC2 more details about data center. I told you whole world is divided into some regions. Under each region you have availability zones. Okay, under each region you have availability zone. Under each availability zone you have multiple data center. Right? So this is by default it is having only one data center and only one UB. What is UB? Can anybody tell what is UB? What is UB? You know what is U? Only B I need to tell. All classes I am calling this U, right? What is U? U is user. B is base. So a group of user is called as a user base. So by default, you have only one data center and you have only one user base. Okay. So what actually we are doing here? So some users are there in this particular region. Okay. They want to deploy some kind of applications where data center is present in another region. Okay. User base and data centers are present in different region. So just like a client server protocol, I told you client server architecture, client has to request some resources to the server. Server has to reply to the client. Okay, for providing the resources. In the similar fashion, this user base, the set of users are requesting some resources to the data center. Like Amazon EC2, you are requesting an instance. Amazon S3, you are requesting a bucket, right? And your data center is going to provide you the resource. So obviously, as there is only one data center, only one user base, so this UB1 is going to map to data center 1. There is no other choice. Okay, if there are two data centers are there, then you may think whether to give to data center 1 or to give to data center 2. But as because here there is uh, only one user base and only one data center, definitely that user base is going to map to data center 1. There is no other possibility. So you have to experiment by taking multiple user bases and multiple data centers. For example, if you go to this research paper, if you go to the page number 5, okay, not page number 5, page number 6. Here you can see they have given 7 different scenarios. What are the scenarios? They said there is only one data center. Data center means what? That is physical machines or servers. So in that physical machine, you can install 50 virtual machines. So our EC2 instances are of nothing but the virtual machines. So in the first scenario, you have to create one data center with 50 virtual machines. In the second data center, second scenario, you have to create two data center. Okay, like cloud analyst, you have one data center by default. You have to create another data center, and the number of virtual machine in each data center is 25. That is the second scenario. Come to third scenario. There is two data center with 50 virtual machine each. Now the data centers are having more virtual machine in comparison to the scenario 2. Third one, two data centers with 50 virtual machine each with peak load sharing. So the approach they have followed here, that is called as peak load sharing. One data center has to share the load with another data center when there is a peak demand. Okay, suddenly the number of users requests are increasing. Then what happens? One data center has to share the load with another data center. Similarly, 50 is two data center with 50 virtual machine, each with peak load sharing and queuing. Queuing, you know, right? Whenever we submit a particular request, it is queued because the resources are free. Then we can assign. If resources are not free, then it has to wait. That you have studied in operating system. That is called as process life cycle, right? So whenever a new request reach, so it has to wait. If the resource is free, then you can assign. Otherwise, it has to wait. Coming to sixth one, here we increase the number of data center to 3. We consider 50 virtual machine in each data center with peak load sharing and queuing. The only difference with 5 and 6 is that 2 data center, here it is 3 data center, each with 50 virtual machine. Now, coming to third last scenario, there are 3 data center, but all the data centers are not equally capable. And in practically also it is true. All the data centers are not practically capable. So 3 data centers are there. They are having different virtual machines. Like first data center is having 75 virtual machine. Second data center is having 50 virtual machine. Third data center is having 25 virtual machine. Okay, with peak load sharing and queuing. So here we consider heterogeneous data center. Yeah, Junali, is there any question? Okay, so there are 3 data center and their number of virtual machines are different, right? But other cases, whatever you have seen in scenario 1 to 6, they are more or less identical data centers or homogeneous data centers. Heterogeneous means the data centers are having different capability. So the number of virtual machines are different. As the number of virtual machines are different, their capability is also different. So these 7 scenarios you have to practice in using Cloud Analyst. Junali, do you have any question? Okay. So let us back to our Cloud Analyst. Here you can see in the right part, you have a button called Show Region Boundaries. And you know what is the meaning of region. So click Show Region Boundaries. Then you can say a colorful map, right? And not only that, it is just like a check on check button, right? So if you click it, not only you are getting a colorful map, but also you are getting different regions. Like here you can see the region is R0, here region is R1, this region is R2, okay, this region is R3, this is R4 and R5. So the whole world is divided into how many regions? 6 different regions. AWS, have you seen these regions? In AWS case also you have seen these regions, right or not? What are the regions? Can anybody tell? What are the regions you have seen in AWS? AWS case, what are the regions you have seen? Please answer.
Sir, the regions were based upon North America, South America, Middle East, Africa, Asia Pacific. These.
Yes. So that is the same thing here they have incorporated in the form of different regions. Right? The concept is same: US East, US West, North America or South America, Middle East, Asia Pacific region, Europe region. So in the similar case, they have also designed these particular regions. Right? The main idea of the regions is that if a region is having disaster, suppose one particular part of the world is having some disaster or earthquake or any other thing, right? Any natural calamity also, right? It is not going to impact other part. And we believe that whole world is not going to be face the same problem in the same day. If the same thing happened in the same in a particular day, then entire thing is going to be collapsed. Right? There is no data center, there is no internet, there is nothing. Okay. That is the reason why it is divided into number of regions. Right? And also security perspective, or you say legislation perspective, jurisdiction perspective, uh, these regions are need to be separate from each other, right? That is also the reason why we like data protection policy. So we believe that in one particular region, the same data policy is adopted. Another region, the data protection policy may be different. So for that particular region, they divided the whole world into different regions, right? And you know what is the use of exit button? Once you click exit, you will be again back to NetBeans, right? If I click exit, then again I have to go to NetBeans to start my simulation. Similarly, if you click run simulation, you know user base, there is only one user base, there is only one data center. Once you click run simulation, UB1 is mapped to data center 1. I told you UB is nothing but a set of user. Again, each user is having multiple requests. Like in your class, you have 20 students. Like each student may have multiple queries. One student is having one query, another student is having 5 queries. So, but as there is only one data center, so what happened? The UB is going to be mapped to the data center 1. Okay, in which they have calculated the response time. What is response time? We have studied in operating system. What is response time? Can anybody tell about response time? Operating system, we have studied response time.
So the time duration between once the process enters and when it is serviced. So that's the response time.
Yeah, that is called as fast response. Once you submitted a request, suppose you have submitted a request at 4 a.m., but you got response at 4:10. So response time is 10 minutes, right? So here it is saying average response time is 300.1 millisecond. Maximum value is 389.1 millisecond. Okay, 369, I think. Minimum is 237.1 millisecond. So all the performance measures are calculated based upon the minimum value, maximum value, and average value. Then you may ask me how they have calculated this one, what task is submitted by these users, what is the capability of data centers. That you can get from these two buttons. One is called as configure simulation, another is called as define internet characteristics. Okay, so once you click this run simulation button, it will execute your simulation and you can see your result here. You click display detailed result, you can get much details about your result here. Okay, for example, let me show you the result, then I'll go over details. So it is showing two important performance measure. Performance measure is nothing but the metrics used to check the performance, right? Like CGPA, SGPA. In the student case, they are the performance measures, right? So here you can see the overall response time. Not only you are calculating response time of a single user, but you have to calculate response time of multiple user, right? So you have to check overall response time. So suppose you have submitted 100 requests, you have to calculate response time of each and every request. Finally, you have to calculate overall response time. Similarly, there is another performance measure that is called as a data center processing time. Okay, so in order to process your request, suppose your data center request is reached to a processor or a virtual machine. The virtual machine will take some time to execute it, right? So that processing time also we are calculating. Three different measures we are calculating. What is the average value, what is the minimum value, and what is the maximum value. So obviously, minimum value is less than equal to average value less than equal to your maximum value. All these values are calculated in millisecond. Now, you can see response time by region. We have only one, that is UB1. Okay, UB1 is present in one region. So its average time is noted here, the same time, because it is having only one user base. So as it is having only one user base, we are getting the same values, right? When you go for multiple user base, you can get region wise the values. Similarly, user base, this is in the graphical point of view, the response time and other things, right? Similarly, you can get data center request servicing time. So in which also you can get the data center servicing time in average, minimum and maximum in millisecond. Okay. And also you can see if this is the user base and you have one data center, and if you calculate the cost, so you can say total virtual machine cost is $0.51. So if you execute such type of application in user base 1, you can request to data center 1, right? So the cost you will pay is $0.51. But the data transfer cost also you have to pay, because your user base and the data center, they are present in different region. Even if they are present in the same region, you will pay some cost, but the cost is less in comparison to two different region. So that cost is calculated as $0.06. So total cost is nothing but total virtual machine cost plus total data transfer cost. And if you calculate the total, you are getting here $0.57. So you have estimated that if this particular user base is going to be submitted from this region, which is going to be executed in a data center present in another region, the tentative cost is this much. Right? That is the overall part of this simulation result. Okay. So now what you can do, you can export this result. If you want, you can store this result in your, let's say I'm writing first one is scenario1.pdf in your document folder. You can go to your document folder. If you want, you can see this result in a PDF form, right? Okay, the same result which we have discussed, the same thing you can get in your uh, document folder. Now, let us see the important part. These are very simple, but let us go to these two buttons and understand each and everything which is inside the configure simulation and define internet characteristics. Go to configure simulation. Under configure simulation, you have three tabs. One is called as main configuration. This is not only the main configuration for user base, but also the configuration of your data center, right? Then you have another tab, especially for data center configuration. That one is called as advanced one. Okay. So again, let us understand the main configuration. In main configuration, you have to select what is the simulation duration. Simulation duration can be selected starting from minutes to days. But if you select days, the simulation is not going to run for that many days, but it will show you the result if it lasts for that many days, right? Like suppose you want to run a particular program, a program may takes, let's say, 1 day to complete. Okay, a program may run for 1 day and it will show you the result, right? But this simulator within a fraction of seconds, it will show you the same result which you want to go get after 1 day. So the tentative cost it will show you that you have to select here. So by default it is 60 minutes, right? So you have also seen when I click run simulation, it is not taking 60 minutes to show my result, right? Now coming to the details of user base. So here you can understand what do mean by user base. So a user base is having a name. Like here you can say UB1. I can rename it U1 or something like that. And it is available in which region? Region number 2. Right? If you cancel it, you can see UB1 is under region 2. So if you want to change it to some other region, for example, I want to change it to region 0. That also I can do. Okay. Now you can see where is your EB1? EB1 is in region 0. So your boundary. So you can see EB1 is shifted to region 0. That you can do. Right? And what is a UB1? UB1 is having certain properties or certain parameters you can say. First parameter is how many requests per user per hour. For example, in your batch you have 20 students, right? But each student wants to give 10 requests. So it is 10 requests per user per hour. Within a particular time frame, like here you consider per hour, how many users are there and how many requests each user is submitting, that you need to give. So here it is showing 60 requests per user and that is per hour. So if there are 10 users, then 600 requests per hour it is generating, this user base 1. Now, not only you are generating means that is nothing but the instructions. When you generate some request, that is called as instructions. But such instructions are having some data, right? For example, here the data size per request is 100. Per request, the data size is 100 bytes. Like if you have written a particular program, the program is having some data size, right? That data size, in average, it is considered as a 100 bytes per request, right? Now, in pricing scheme, I told you there is a in pricing scheme. I told you that there is a peak price and there is a off peak price, right? What is the difference? Anybody tell peak price with off peak price? What is the difference? Peak price to off peak price. Peak price and off peak price. What is the difference? Peak price means generally considered as 12 noon to 12 a.m. Okay, this time, current time is under the peak hour. And night 12 to 12 noon is considered as off peak hour. So here you can mention what is the peak hour time and what is the peak hour start time and peak hour end time as per GMT. For example, here it is 3 and it is 9. So peak hour starts at 3 GMT and peak hours end is 9 GMT. And average number of peak users are 1000. Average number of off peak hours are 100. Obviously, peak hours number of users are more. Off peak hour number of users are less. Okay. Now, what you can do, you can create as many as number of user bases are possible. For example, if you want to add another user base, you can select a particular region, right? You can change this parameter. For example, I can select average number of peak hour is 10,000, off peak hour is 1,000. Okay. Similarly, I'm adding another user base. You say peak hour starts at, let's say, 1 and peak hours ends at, let's say, 11. Right? Now I am creating another user base in region number 3. Okay, I am mentioning number of requests per user is 600. Data size is 1000. Okay, something I randomly am adding. User base 5 is situated at, let's say, region number 4. Right? And let's say number of peak hours are more, of peak hours are obviously less, right? Some value I am written. Then user base 6 in region number 5 having these characteristics, right? So how many users base I have created? I have created 6 different user base. Okay. So when you click done, you can see, okay, here you can see how many user bases are there. 1, 2, 3, 4, 5, 6. Total 6 user bases are there, and in each region you can find a user base. Okay, up to this it is clear. Any question till now? Please respond.
No, sir.
Okay, so you can create as many as user base. For example, I can create user base 7 and I am locating user base in region number 0. Not necessary that in each user base it will be, sorry, in each region you have only one user base. You may have multiple user base also. Like here you can see now UB1, UB7, they are part of region 0. Okay, multiple user base in a region is possible. That you can create as per your requirement. There is no question about that, right? So, so like as I said, you have to take different scenarios to run. So you try as a assignment. You can try as many as number of user base is possible, so that you have an idea that how the results actually varies with respect to the number of user bases. Right? That's why uh, you have to conduct multiple scenarios, not only the 7 scenarios mentioned in the paper, but as many as scenarios are possible. You try to focus on that scenarios, and uh, you see how it really affects the scenarios. Okay, how the results affects with this respect to these scenarios. Okay, so now you can see here there is another option here under main configuration, that is called as your service broker policy. Okay, you can see service broker policies are written, right? So what is service broker policy? How many service broker policies are showing here? What are the service broker policies showing here? There are 3 policies. Okay, service broker policy can be selected as cloud data center, that is called as CDC, optimize response time, that is called as ORT. Another is called as reconfigure with dynamic load. Okay, RDL is nothing but reconfigure dynamically with load, that is called RDL. You can select any policy. So for each scenario, you have to choose different policies to check their performance, right? So what is the main purpose of this policy? The main purpose of this policy is, or you can see CDC or ORT or any policy you are choosing, right? So the main objective of this policy is to handle the traffic routing between user base and data center. In order to connect the user base and data center, the routing process is done by these 3 policies. So how these routing policies are done? Like first one you can see here, it is written closest data center, right? So obviously, as the name suggests, CDC is closest data center. So first you have to check your user base and its region. Based upon that, you will find a data center which is closest to your region. But by default policy is your CDC only, right? CDC is the default traffic routing policy, and it assigns the data centers for user bases by considering the network latency. Network latency means what? Network delay. So when the delay is minimized, the delay is going to be minimized if the region is same. If the region is very far away from there or each other, then definitely network latency is going to increase. So in order to do this one, what this policy is doing, This policy actually maintains an index table. If you go to the code, you go to the NetBeans, okay, you can expand this thing, go to source package. Under source package, you can find a service broker. All of you study these codes because you are comfortable in Java. So I hope you are comfortable in Java, so you can do it, right? So this is for best response time. You read its policies, whatever written here. You understand the packages. The dependency of these packages you can find from this particular paper. So this is the diagram which we call as a class diagram. So here you can see which class is dependent on which other class. The dependency you can find from this particular class diagram, right? So yes, so here they are maintaining a index table, as I said, index table of the data center by their regions. So whenever a request is received from a user base, so what the internet is going to do, or a manager, centralized manager, what the manager is going to do, the manager gets the nearest data center region in terms of latency or delay. Okay, for this, they have to inquire what the internet characteristics, define internet characteristics is there. Okay, and once they inquire about the internet characteristics between two different regions, they allocate the request to the data center in that region. But it is also possible there are more than one data center in the same region. But here we have not created that scenario. We have created only one data center in one region. Till now, we have not created one data center per region also, right? So, but if you have multiple requests in multiple data centers are there for the same user base in the same region, then one of them you have to select randomly. Okay, that's why this policy is always called as service proximity policy. Proximity means closeness policy. So let us go to internet characteristics and let us see what is there in the internet characteristics. In internet characteristics, you have two things. One is called as delay matrix, another is called as bandwidth matrix. You know, if bandwidth we can increase, delay will be decreased, right? If delay is more, that indicates that the bandwidth is less, right? So what you have here, first one is delay matrix says that the transmission delay between region. How many regions are there? There are 6 regions are there, 0 to 6, so 0 to 5. Similarly, here also in column and row, we are taking 0 to 5 region. So these values indicates delay from one region to another region. So if you see the diagonal values are nothing but delay from that region, one region to the same region. Like region 0 to region 0, 25. Region 1 to region 1, 25. Region 2 to region 2, 25. Region 3 to region 3, 25. Okay. But if you see other, like here you can see region 3 to region 4. What is the value? 500. So it is more. Okay. So that you have to determine. That's why I told you internet gets nearest data center in terms of network latency by querying to the internet characteristics, and based upon that it is going to alert the data center, right? Similarly, bandwidth matrix is nothing but the available bandwidth between regions for the simulated applications. The unit for delay is millisecond. Bandwidth, you know, we are saying 10 Mbps, 1 Gbps, 100 Mbps. So unit is Mbps. So you can see within the same region, the bandwidth may be more. Like here you can see region 0 to region 0, bandwidth is more. That's why the delay is less, right? So between two different regions, like region 1 to region 1, it is 800. It may be any arbitrary value, but based upon that, the delay also, these two metrics are dependent metrics. Okay, one delay is you are increasing means another it is impacting the bandwidth, right? Or bandwidth to delay. Okay. So like that, these are the two things that is available in the internet characteristics. Now again, come back to our cloud analyst. So now if I ask you for user base 7, which data center is going to be assigned? Can anybody tell if I choose cloud closest data center? Assume that the other in each and every region you have a data center. In each and every region, like total we have 6 regions, you have data center. Now my question is that if UB7 is there, which data center will be assigned to UB7 if I follow CDC policy, closest data center policy? Any answer? Which one? UB7 is present in which region? DC1, yes. Answer is DC1. UB7 is present in region 0. The closest one is DC1. Okay. Now coming to second policy. Note that CDC is the closest data center, right? So always not necessary that the closest data center will give you better response time, right? If the like here you can see there are multiple user bases under region 0. But if you see other regions, there is only one user base. So there is more load to data center 1, assuming that each and every region you have a data center, right? Always there is a more load to data center 1 because more than one UB is there. So maybe for DC1 is serving UB1, but DC1 also assigned to UB7, which results for response time. So in order to avoid that, we have another policy that is called as optimized response time. Okay, what we are doing in optimized response time? In optimized response time, this policy uses our closest data center policy only and determine the region of the data center. First is you have to determine the data center when you are allotting a particular user base. Then it uses the latest recorded processing time and network latency and calculate the expected response time. Suppose you have two data center, let's say data center 1 and data center 2. You are calculating the response time with data center 1 as well as calculating the response time with data center 2. Okay. So after calculating the response time, you will come to know which one is best, right? So if the data center has least expected response time, let's say DC2 is having least expected response time, then it chooses DC2. Otherwise, it chooses DC1. Okay. Otherwise, also you can do if both are having same expected response time, then you can select one of the data center with equal probability. Okay. So in this way, the problem can be solved, right? If there is a multiple data center, check the response time. Based upon the best response time, you assign it. Otherwise, you can assign one of the data center by considering equal probability, right? So this particular algorithm is also called as performance optimized policy. Some of the papers they highlighted this is the performance optimized policy. Third one, that is called as reconfigured dynamically load. So this RDL actually share the load from one data center to another data center. And this is a distributed system. One data center may get more request, another data center can get less request. Like I told you about region 0. In region 0, you have more request, other regions you have less request. So what RDL is actually going to do, it shares the load from one data center to another data center if the performance degrades above a particular threshold. What is the condition? The condition is you have a threshold. If you exceed that particular threshold, then it is going to move from one data center to another data center. Okay. And this particular threshold is predetermined based upon various parameters like loads and other things they need to consider in order to choose that particular threshold. Okay, so you have to choose one of the policy in the service broker policy. Now, coming to next one, that is called as application deployment configuration. In under application deployment configuration, you have data center. Like here, you can see a data center is having 5 virtual machines. But what I told you in scenario 1, in scenario 1, you have to take, okay, these are the different regions. Okay, UB1 is North America, UB2 is South America, Europe, Asia, Africa, Oceania, right? And their GMT time, peak hour, peak hours time, peak hour local time, and peak hour as per GMT. How many users are on means active in peak hour? How many users are there in off peak hour? Obviously, this is more than the last column, right? Now go to scenario 1. In scenario 1, you have to create one data center with 50 virtual machines. What you have to do here, instead of 5 is the default one, you will write 50. The number of virtual machines in the data center 1 is 50. What is the image size? Image size is 10,000. Like whenever you are installing a particular software like Windows and other things, you are getting CD or DVD that is having your image file. So the maximum image file is having this much size. Memory is 512, bandwidth is 1000. Okay, but if you try to create another data center, it is showing an error. What it's saying? All available data center seems to be allocated. Please create a new data center before you can create further allocation. So whatever data center you have created, they are already occupied. So in order to add a new data center, you have to create a data center. That's why especially you have a tab that is called as data center configuration. So let us go to data center configuration. In data center configuration, what you have? You have data center 1. Data center 1 is there in the region number 0. And it is following one architecture that is called as x86 architecture. So you know there are two architecture, x86, x64 architecture. So it is having x86 architecture. Operating system that is used in the data center 1 is Linux operating system. You have seen in Amazon EC2 also. You can go for Linux, you can go for Ubuntu, you can go for Mac operating system, Windows operating system. Similarly, you know what is VMM? VMM is nothing but your hypervisor. Hypervisor is generally used to, hypervisor is there to create a virtual machine, monitor the progress of the virtual machines, right? Managing the virtual machines. So here the VMM used is XCL. So there is no other option given here, but if you want, you can add it also. Now we see what are the costs associated with the data center. There is a cost per virtual machine dollar per hour. If you are using a particular virtual machine, then per hour you have to pay this much amount. Memory cost of using the data center is $0.05 per second. Storage cost is $0.1 per second. Data center cost, transfer cost, $0.1 per GB. Physical unit is 2. You can change this thing. Okay, there is no problem. You can change. Suppose I want to go for 4 physical unit. Simply I'll select here, copy. I want to copy 2. So earlier it is 2, but now it will be changed to, okay, here if you can change, you can see now physical unit is changed to 4. So you can see in data center 1, under a data center, you are creating 50 virtual machines. So these 50 virtual machines may not belong to one physical machine. Like here, I have created 4 different physical hardware. Using this 4 physical hardware, you can create 50 virtual machines. So each hardware is having memory in a megabyte, storage in MB, available bandwidth, number of processors, processor speed in IPS, and VM policy. There is 2 VM policy. One is called as time shared policy, another is called as space shared policy. Find the difference between these two policies. Time shared means the execution time. Suppose you are processing a particular user base. So along with that user base, if you can execute another user base, then that is called as time set policy. Space set, whatever space is given to a particular particular request, that request is also given to another one. Like one physical machine, you are creating multiple virtual machines. That is called a space sharing, right? So like that, you can select some policy here. Now, if I create a data center here, let's say in region 1, another data center, let's say in region 2, okay, another data center in region number 3, will create as many as data center possible, even if in multiple data center per region also you can do it. Okay, 5. Now I am creating another data center and I want to create this data center in region number, let's say 3. So now region 3 is having 2 different data center. But when you click done, you will not see the data center here, because the data center, whatever you have created, that is under data center configurations. But you have not added those data center in main configuration. So in order to do this one, you have to add new, create data center 2, add new data center 3. So in the setup scenarios given in this PDF file, it asks you to create maximum 3 data center. But you can create as many as data center, create different scenarios. Like here I can take data center 4. For example, I'm writing data center 2 is having 75 virtual machines. Okay, data center 3 is having 25 virtual machines. Then data center 4, data center 5, data center 6. There is 2 DC5, that's why I'm getting error. Okay, so let me create data center 7 and data center 6. Okay, now you have created data center. So once you click done, you can see in each and every region, now you have data center. Region 0, you have 2 user base, 1 data center. Region 1, 1 data center, 1 user base. Region 2, 1 user base, 1 data center. Region 3, 2 data center, 1 user base. Region 4, 1 data center, 1 user base. Region 5, 1 data center, 1 user base. Right? So if you run, now you are running with which policy? Closest data center. So obviously it will assign to its own data center. Okay. Okay, it is asking me to restart. So let me save this one as nitw.sim. Okay, let me close it. Okay. Then let me rerun it. Then I'll open this configuration, load configuration, nitw.sim. Now all these things are coming. Okay. The only thing is that here you can see in region number 0, you have multiple user base with 1 data center. But region number 3, you have multiple data center with 1 user base. So once you run this simulation, so as you have multiple data center, it will take a little bit time. Okay, but not 60 minutes or 60 hours or 60 days. So you can see their data center, respective data centers are capable to handle that particular request. So whatever result you are getting, please note down that result. Then change the configurations. So you can see these are the times it is coming with respect to the user base. This is with respect to the data centers. And the cost you can see you have to pay $30.71 if you want to run these user bases in the data centers. Right? So what I am saying, you can run the same simulation with the optimized response time. Okay, let me run it. Okay, it is asking me to again rerun, restart the simulator. Okay, let us restart the simulator, load the files. Okay, once you load the file, change it to optimize response time, click done, then run simulation. Okay, just to compare, increase the number of user base in a particular region, increase the number of data center in other region. Okay, So check that increasing number of user base by keeping one data center or increasing number of database in one user base. So other user bases, is it mapping with that particular data center or not? That you have to actually check, so that you will know a little bit more clarity, right? Here they are capable, right? Like two user base means it is small only, right? It is not moving from one data center to another data center. So you are getting the same cost, right? But when you increase, sudden increase, you can see the result will slightly vary. Okay, so this is all related to the data center. There is another tab that is called as advanced tab, right? Again, this advanced tab, okay, this advanced tab is having advanced configuration is having four things. One is called as the user grouping factor. So actually, this is the user grouping factor of the user base. Similarly, there is another one is request grouping factor of the in the data center. Third one is executable instruction length for request in bytes. Fourth one is called as a load balancing policy. Okay. So what is this? The user grouping factor is nothing but number of concurrent users from a particular user base. You have created user base. Under a user base, you have multiple user. Again, multiple users are having multiple requests. So how many users are concurrent user from a particular database? That is called as a user grouping factor. You can see also the definition is number of simultaneous users from a single user base. Similarly here, the request grouping factor is the number of concurrent users request supported by a single application server instance. Here you can see number of simultaneous requests a single application server instance can support. So that you have to specify. Similarly, here you can see executable instruction length per request is considered as 100 bytes. Now, if you go for load balancing policy, what is the purpose of service broker policy? The purpose of service broker policy is to map user base with the data center. But the purpose of this load balancing policy, which you can see here, round robin, equally spread current execution load, is called as ESCL, or throttled, which we call as TH. So the main purpose of these policies is to assign the request across the virtual machine under a single data center. Under a single data center, you have seen in the first data center, how many virtual machines are there? 50 virtual machines are there. So how you are going to alert these virtual machines? Okay, these 50 requests to these 50 virtual machines, that will be decided based upon the load balancing policy. So if you go for the first policy, which is a default policy, that is called as round robin, and all of you know about round robin policy. So it assigns the request to the VM in a circular fashion, or sometimes we call it round robin fashion. Okay, 1, 2, 3 order, right? So obviously, as it is assigning in a particular order, no guarantee that you are selecting an appropriate resource for a particular request, right? So what you can say, this policy does not consider the current load on the virtual machines. Like you are assigned, if there are 16 requests are there, and if there are 4 virtual machines are there, so you will say for virtual machine 4 requests, for virtual machine 4 requests, right? But you are not considering what is the current load on the virtual machine. So as a result, what happened? One virtual machine may be overloaded, another virtual machine may be underloaded. Similarly, there is another policy, that is TH policy. Okay. So this TH policy is having a load balancer. The name of the load balancer is throttled VM load balancer. And how it is assigns? It assigns the request to the virtual machine by considering a threshold. So for this load balancer actually maintains a list of virtual machines, and it also note down what is the status of these virtual machines, whether this virtual machine is busy or this virtual machine is available. Okay, and it also, this throttle policy also restrict the number of requests per virtual machine by considering a threshold, which is called as throttling threshold. So whenever a request arrives to the load balancer, throttle scheduler identifies the next available virtual machine. Which virtual machine is available? Because you are maintaining the status is busy or available. And it assigns the request to that virtual machine by changing the state from available to busy. But if a request cannot be processed, is, let's say, virtual machine threshold is exceeded, okay, all the thresholds are exceeded, then the request is queued until unless one particular virtual machine change its states from busy to available, right? So in this way, actually, this scheduler, throttle threshold scheduler is working. Okay. Similarly, there is another load balancing policy that is called as equally spread current execution load. Okay, it is having a policy that is called as active VM load balancer policy. It also maintains an index table of the virtual machine and number of currently allocated requests. So initially what it is doing, all values are initialized to 0. So whenever a request arrives, the load balancer, okay, that is equally spread current execution load, identifies a virtual machine with least active load. If there are 5 virtual machines, you have to choose which one is having least load. Okay. Once you identify least loaded machine, you allocate the request to that virtual machine. And once a virtual machine is allocated, you have to acknowledge to your data center controller. Because your data center controller will consider your load. It will not assign more loads to you if it is having more load, right? Here, if you are having more requests. So once a request is sought, the load balancer of the virtual machine is again decreased. And this index table is periodically updated. So in this way, actually, the load balancing policy actually works. So what you can do as a part of assignment, so you can take up this challenge and consider developing a new broker policy, which you have seen in under main configurations. You can propose your own broker policy. Similarly, you can propose your own load balancing policy. Okay. Another important policy which is there, which is not shown in this GUI, that is called as VM provisioning policy. What is VM provisioning policy? It actually maps virtual machine to the physical machine. There are 3 types of mappings we are doing here. First mapping is user base to data center by using service broker policy. Second one is in a particular data center, if you have multiple virtual machines, how the request is going to map to these virtual machines. That is called as your load balancing policy. But the third policy is that where the VMs are mapped to the physical machines, mapping of VMs to the physical machines. But if you go for this particular tool, the cloud analyst case, you will find they are using random virtual machine provisioning policy. Okay, so if you can design your own policy as a part of your project, this is a subject project, or you can say your minor or major project, whatever you have in your final year. So that is really you can add in with this cloud analyst, and you can see the performance of your own scheduler policy, right? So try to go through this course what is given in this cloud analyst folder. Okay, you will find the policy related to service broker here. Okay, the networks related you can find here. Okay, delay metrics and other metrics, topological graphs, how they are connected, you can see here. And under data center, you will find a round robin policy. These are nothing but your load balancing policy. Yes, this VM load balancer policy is nothing but the default policy. It is uses random, right? Random to assign the VMs to the physical machines, right? So if you can change it and incorporate with the cloud analyst, you need not modify other units like user base, data centers. Other you need not modify. You have to particularly focus on this modification of load balancing policy or service broker policy or VM load balancer policy. So it will be really a great addition to this particular tool. In fact, I'll share with one of the paper with you where one of my group, you can say BTech group, Okay, they have developed some policy and they have inbuilt with this cloud Analyst. Okay, and which shows better performance than these traditional load balancing policies and traditional service broker policy. So I'll say that paper, go through that paper, you have little bit idea related to how actually the cloud analyst works. Okay,